Hi guys, welcome back to QBT. Today we're talking about current and voltage in series circuits. Okay, so current and voltage are distributed differently depending on whether they are in a parallel or series circuit. But in this video we're going to be talking about how they are shared in a series circuit. Okay, so in a series circuit, the voltage that goes in is actually shared across all the different components in the circuit. Okay, so it splits differently depending on how many components there are. But in terms of current, the current that goes into a series circuit is the same across each component in that series circuit. So to explain what I mean by this, why don't you check out the tutorial video that I've made, and hopefully it will help you understand this concept a little bit better.
Okay, so let's use our knowledge of the equations that we have about how current and voltage are distributed in a series circuit to answer this question. So the question is, calculate the voltage across each component in the circuit below. Okay, and we can see in this circuit that we have a series circuit because all of the components are connected in series. None of them are in parallel. Okay, so step one is identifying the kind of circuit that we have. And this helps us to understand which equations we're using, because we know that in a series circuit, V in is equal to V1 plus V2 plus V3, and then current in is equal to I1, which is equal to I2, which is equal to I3. Okay, so it's the opposite of parallel, right? The equations are opposite of each other. Okay, so we've done that. That's great. But it's asking us to find the voltage across each component. Okay, well, how can we do that? Well, let's start here. We know that the current leaving the battery is 12 amps. And we also know that in a series circuit, the current across each component is equal, which means that the current across R1 is 12 amps. And it's also 12 amps in R2, and it's also 12 amps in R3, right? And we also have the resistance of each resistor. Now, using our equation here, ravioli, we can use this, right? We can use this to calculate the voltage because V is equal to IR. So V1, right, here, would be 2 times 12, which would be 24 volts. V2 would be 6 times 12, which would equal 72 volts. And V3 would be 3 times 12, which would equal 36 volts. So we've used our knowledge of how current and voltage are distributed in a series circuit to find the voltage across each component. But what if the question also wanted us to find the voltage that was coming from the battery? What if it wanted us to find the voltage that was leaving the battery and heading through all the components? Well, we would have to use this equation here, wouldn't we? We'd have to use our V total equation, and we can see that the voltage in is equal to the voltage of each individual component. So we would have to add them together. We'd say V total is equal to 24 plus 72 plus 36. This is how we would get our answer. And when you're doing these questions, what you need to do is you just need to break them down into their individual components, all right? You need to see which circuit you're dealing with. Is it a series circuit? Is it a parallel circuit? And then we head over to our equations over here. Am I dealing with series equations or parallel equations? And then we look at the information that we have and we ask ourselves, okay, what can I find with the information that I have? If I have current and resistance, surely I can find voltage. And if I have resistance and voltage, surely I can find current. So that's how it works when you're doing these sorts of questions. I hope this was helpful.
Okay guys, so hopefully that was helpful and it's helped you understand a little bit better how current and voltage are distributed in a series circuit. That's it for now, but in the meantime check out our other videos on resistance and current and voltage. They're linked in the description below. And if you have any questions, then by all means post them in the comments, like, subscribe, it helps grow the channel, and we really appreciate it. But we will see you next time. Okay, bye guys.